Video 17A, wind continued. So we're going to continue to look at wind generation. Now, in the first video, I tried to explain all the difference in mixing the two up. You would not normally mix wind energy into a system. You'd use the conventional fossil fuel plant at highly efficient three-phase alternating power. And you have coal or turf or whatever heats the engine, heats the boiler. It can be nuclear, but it takes 9 hours to start up. Nuclear takes longer, but it takes 9 hours to start up a coal-fired steam condensing plant. And then you can have a combined cycle, which is a jet engine and a boiler, and that can take 9 hours as well. A jet engine on its own, that's a open cycle gas turbine, takes just about 15 minutes, the same as a jet engine taken off at an airport. And a diesel engine is almost instantaneous. So is hydro. So we see that you have the old plant there. Now, we see also you cannot use 100% renewable energy, and therefore that begs the question: at what point does it? Do you have to stop using it? And at the moment, we see that that's 60%, but that doesn't tell you what use it is. There's a big debate on that. I claim wind is never any use, whereas other people say it is use. So it's the same as putting salt on your lunch. A little of it's all right, but if you put a half a pound on or a half a kilo, you'll very soon ruin your lunch. So that's the big key. It cannot be used 100%. Therefore, that begs the question: how much of it can you use? Now, so among the studies that are carried out, and we go now to look for studies, because I think I could talk for years about the technical aspects of generating mains electric power, and some people just don't want to believe it, and some people just find it very hard to grasp. But those videos 1A, 1B and 1C are vital to grasp the concept. So this is the Pentek Studies out of Colorado, and they produced a study on wind energy, and there's two systems over there running, and they carried out a study. Now, a lot of Greens and certain people will reject any study that's to do with anyone that's involved in fossil fuel. But yet you buy a car, you'll read the instructions from the manufacturer, and it's designed to run on fossil fuel. If you buy a gas cooker, it runs on electricity. If you buy a coal-fired cooker, it runs on coal. You'll read the directions. So this idea that you can't use the directions or the findings of a manufacturer or any other study group because they may have a vested interest, you take it with a bit of caution. But it is nonsense to say you can't use them. I mean, the pilots are trained to use jet planes that burn fossil fuel. You'd hardly go and fly on one that was trained to ride a donkey. I mean, it's ridiculous green nonsense that they go on with. So the Pentek Studies, if you want to see it here, what it says is how less became more, wind power and the unintended consequences in the Colorado market. So we'll show it to you here now if you can see it. Now, to call it out again, you can search it on Google or any other DuckDuck or any of those. How less became more, wind power and the unintended consequences on the Colorado energy market by the Independent Petroleum Association of the United States. Now, all I'll read to you is just a little bit of it here. What they found, to their shock, and I seem to be the only one that's not shocked about this, was that it was pure better with none at all. That's what they found. So here's what it says. Now, there's two systems operating in the south of America, around Texas. It's the PSCO, the PESCO, and the ERCOT. There's two. It's like ESB in Ireland and Energia, or E.ON in Germany and PowerGen in Britain. They're just the companies that run it. The study details the surprising conclusion that the use of wind energy in the PSCO and the ERCOT context results in increased sulfur dioxide, nitrous oxide, and in the case of PSCO, CO2. Increased it. The mechanism driving increased emissions is the need to cycle coal facilities in order to accommodate wind. You have to speed it up and slow it down and speed it up and slow it down. Right? Which is considered a must-take. In other words, you have to take wind by law. You have to take it if you can use it. You only can refuse it where you simply cannot let in any more. A must-take resource due to the respective states' P or PS mandates. When wind generation comes online, generation from coal and natural gas to meet demand Right. When wind when wind generation comes online, generation from coal and natural gas plants is curtailed until the wind subsides. So they reduce down the coal while the wind's blowing. Then their generation is once again ramped up to meet demand. Cycling coal units in this manner drives the heat rate up and their operating efficiency down. Okay, resulting in higher emissions of CO2, SO2 and nitrous oxide, NOx, now, than would have been the case if the units have not been cycled. Now that study, you can read it yourself. But essentially, when you let in the wind, you have to keep it balanced by the coal fire or whatever other system, and that has to be throttled up and down, and that makes it hugely inefficient. And what you lose on that, the wind tends to bring it up, it tends to gain, but the big question is, if you had no wind at all, were you better off? I maintain you were. There are different studies on that. So that's the Pentek study out of Colorado. So there's another study here, and the people here are Irish, and they have no reason to tell lies, and I know people in this organisation, and they tell me this is the situation. Right? So you're trying to make a machine behave differently because for political reasons, you know. And you know in my open video, the fact that 1 and 1 are 2 and 2 are 4, and neither 5 nor 3 has made men's hearts sore and always likely to be. And of course the only one that can make 2 and 2, 3 or 5 is a politician, as we see, and that's why they're driving this. So the study we're looking for, and this is very important, is impact of wind generation. I'll call it out to you now slowly. Impact of wind power generation in Ireland on the operation of conventional plant and the economic implications, by the ESB National Grid, February 2004. I know you can't probably see that, but I've read it out to you there again. Impact of wind power generation in Ireland on the operation of conventional plant and the economic implications. So this is the Irish grid in 2004. At that stage there wasn't the pressure on to go for all this wind until the Greens took power in 2008, and they drove everything absolutely mad. So what you need to do with that study, if you go into it, do not try to read it all, it's too long. Just go to page 24 and read the paragraph, read number 6 here at the top, capacity credit. Right. Now capacity credit is the actual benefit of any generation plant, including wind. So they picked two scenarios, 5,000 megawatts and 6,500 megawatts, and in Ireland before the wind came on, that's exactly what we had, about 6,300 megawatts of ordinary generating plant, of which 300 megawatts was river hydropower. So they picked the Irish system as it was, and here's the result. Now, as increased amounts of wind are added to the system, then the adequacy improves. So what they're saying is that you bring in a little bit of wind, the whole thing improves, and you can drop off a bit of other sort of plant, hot plant. As a result, amounts of conventional thermal plant may be removed to restore the adequacy to criterion level. So that just means bring it down to the right level where demand and supply is equal, right? The quantity of conventional plant is termed the capacity credit. So the amount of conventional plant that you take away because of another generator, such as wind, is capacity credit. And that is attributable to wind. Now, in order to try and make wind work, they changed this concept to load factor. But capacity credit is the proper way. What you save, in other words. Now, here's the very important now down here. You can see it here. However, it is an unfortunate fact that the contribution to adequacy of additional amounts of wind decreases progressively and tends towards zero, Z-E-R-O. Consequently, the incremental capacity credit of increasing wind power generation tends towards zero. This effect is demonstrated in figure 16. And in this figure here we see bar charts. And you can see that as you add wind, you get very little. When you look at it there, you get very little saving. And this is the law of diminishing returns. Now, on the next page, page 25, you get this graph here. See it here. And you can see that as you put in a little bit of wind over here, you get a greater reduction up here. But as you go over here more, you get less. So you get to a point where you put in 1,000 megawatts of wind and you save nearly no oil or gas or coal. And it gives the figures here under it. So essentially you could put on thousands and millions of megawatts of wind. And somewhere an odd day here and there, you might get a very calm day, but there'll be a little breeze on top of a mountain, you get a little benefit. The cost could be £1 million per customer just to keep that going. So that report is very, very, very important, right? So that means that wind does not displace fossil fuel pound for pound, kilowatt for kilowatt, megawatt for megawatt. And people think it can be put in a bag and treated like groceries. It's a totally different concept. It's a totally different concept. Wind generation is used nowhere. If I wanted to take a country house and run it on a wind turbine, I could put in batteries. When the wind would subside, I'd have a bit of power for maybe a day or two. And then that's gone, you have no more wind. So it hasn't been successful anywhere. Anywhere it's been used, it's augmented by hydro or by a diesel or petrol generator or some other form of fossil fuel generator. And that's the unfortunate fact. And that's the language used in this report. The unfortunate fact. That's it. However, it is an unfortunate fact that the contribution to adequacy of additional amounts of wind decreases progressively and tends towards zero. Why? Because it's a machine. It's not a political animal. It's a machine. And in a machine, 2 and 2 are 4. 2 and 2 are 4. The politician may make it 3 or 5 and you pay the difference. That's the only difference. So I don't know how far I've gone now. Have I made a good job of that? Just an example here now is, here's alternating current. You see the way it goes there? There's a point in alternating current where there's no power flowing. And that's like riding a bike and the pedal is up at the top and one at the bottom. You come to a point when you're riding the bike where you have no power. You have to bring the pedal forward a wee bit to get them going around. And so direct current is the most efficient. Indeed, with alternating current there's a thing called skinning, where the power tends to run out towards the edge of the wire and not used in central core. And whereas direct current, that doesn't happen. But by and large, for all practical purposes, we have lived lovely in Ireland with a proper mean, lean supply of fossil fuel power, which did have emissions. Surely it might have been capable of being improved, but we have decided that the way to improve it is to add all this wind. Now that piece, I'm going to just end this video here. That piece, remember, this is the addition of wind energy on the assumption that it's there, that it's constant. But it's not there, it's not constant. Goes up and down, and between March last year, 2018, was it? No, the 25th of May and the 25th of September last year, we had virtually no wind. So no matter how much wind you had, you have no power. So in that now, we leave that now, and we'll come back then and have a look at some of the methods tried to fix this problem and to get over, as they call, to a low carbon economy, when in fact this will not work. What the solution to that we can explore later, but this cannot work. No matter how much of this you put in, it cannot work. So we'll come back and have a look at that again in another video, okay?